Dear students, now we are going to see the subject transmission lines and RF system. Under that, the topic is stability considerations. On completion of this stability consideration, students will be able to describe the input stability calculation from the stability circle, explain the system output stability. Stability of an amplifier is to maintain an effectiveness in its nominal operating characteristics such as physical temperature, signal frequency, source and load, reflection coefficients, etc. Stability requirement. The stability implies the magnitude of reflection coefficients are less than unity. So capital gamma L, that is load reflection coefficient, is less than unity, and the source reflection coefficient gamma S is also less than unity. So input reflection coefficient gamma in is equal to S11 plus S12 S21 gamma L by 1 minus S22 gamma L, that is less than unity. Output reflection coefficient gamma out is equal to S22 plus S12 S21 gamma S by 1 minus S11 gamma S, that is less than unity. Types of stability: unconditional stability and conditional stability. In unconditional stability, the system frequency is in the range of the input reflection coefficient is less than unity and the output reflection coefficient is less than unity. The load and source reflection coefficient is also less than unity. Unconditional stability: a network is said to be conditionally stable or potentially unstable in a frequency range if the input reflection coefficient less than 1 and the output reflection coefficient is less than 1. Stability circles are input stability circle and output stability circle. The output stability circle, the input reflection coefficient gamma L is equal to 1. So gamma input is equal to S11 plus S12 S21 gamma L by 1 minus S22 gamma L. Its value is equal to 1. So simplify this, take an LCM and cross multiply this. So we are getting S11 into 1 minus S22 gamma L plus S12 S21 gamma L equal to 1 minus S22 gamma L. So multiply the first term inside. So S11 minus S11 S22 gamma L plus S12 S21 gamma L is equal to 1 minus S22 gamma L. So here the gamma L is common in second and third term. So keep it common. So the second term is called as del. S11 S22 minus S12 S21 is equal to del. So substitute that del value in the above equation. So S11 minus del gamma L is equal to 1 minus S22 gamma L. So S11 minus del into magnitude of gamma L equal to 1 minus magnitude of S22 gamma L. So simplify this. So gamma L is common for both the terms. So you keep it outside. So S22 minus del equal into gamma L is equal to 1 minus S11. So multiply S22 conjugate with del conjugate on both sides. So the expression becomes gamma L into S22 minus del into S22 conjugate plus del conjugate equal to 1 minus magnitude of S11 into S22 conjugate plus del conjugate. Now multiply this term inside, gamma L into S22 into S22 conjugate is S22 square minus del square. That is A plus B into A minus B. A plus B is conjugate, so that can be written as A square minus B square. So here S22 conjugate plus del conjugate minus S11 into S22 conjugate minus S11 del conjugate. So gamma L into S22 square minus del square equal to S22 conjugate plus S11 conjugate into S22 minus S12 conjugate into S21 conjugate minus S11 into S2 conjugate minus S11 del conjugate. So from this we are going to find the load reflection coefficient gamma L is equal to, so keep the gamma L as common and remaining terms, numerator term is the right hand side term, cross multiply this term. We are getting S22 conjugate plus S11 in conjugate into S22 conjugate minus S12 conjugate into S21 conjugate minus S11 S22 conjugate minus S11 del conjugate divided by S22 square minus del square. So simplify the above equation. S2 S11 into S22, the term gets cancelled. So S22 conjugate minus the magnitude of S12 into S21 conjugate minus S11 del conjugate by S22 square minus del square. So the load reflection coefficient is equal to, divide the term into 2. S22 conjugate minus S11 into del conjugate as one term, and the next term is another term. So you keep this term in the left hand side of the equation. So the equation for the output stability for the reflection coefficient equal to 1 is drawn in the load reflection coefficient plane and can be written as the load reflection coefficient minus CL is equal to RL. So CL is equal to C output, that is equal to S22 minus S11 conjugate del the whole conjugate divided by S22 square minus del square. So RL is equal to small r, output is equal to S12 S21 by S22 square minus del square. So this figure represents the output stability circuit that is drawn in the load reflection coefficient plane. Input stability circle. The input stability circle is drawn for the output reflection coefficient gamma out is equal to 1 and is drawn in the source reflection coefficient plane and can be written as source reflection coefficient minus CS is equal to RS. So CS is equal to C in is equal to source capacitance is nothing but the input capacitance, that is equal to S11 minus S11 conjugate del the whole conjugate divided by S11 square minus del square. The source resistance RS is equal to or input is equal to magnitude of S12 S21 by S11 square minus del square. The special case for unconditional stability is K equal to 1 minus S11 square minus S22 square minus del square by 2 into S12 into S21 whose value is greater than 1. Here del is equal to S11 S22 minus S12 into S21. Its value is always less than 1. So this figure represents the input stability circuit, the circle that is drawn in the input reflection coefficient plane or the source reflection coefficient plane. So quiz question: for unilateral device, condition for unconditional stability is determined in terms of S parameters. Thank you.